Okay. All right. Once again, good morning, good afternoon, good evening from anywhere you might be joining us from UK, from Canada, from Nigeria. We are delighted to have you here. And my name is Oladapo Babalola, and I'm one of the co-founders of DevOps as a Service Nigeria, which is a free mentorship platform in Nigeria to raise and train the next generation DevOps practitioners that will go out there to innovate and disrupt their IT spaces. So we started this bootcamp a few weeks ago, and today is day 3, or will I say week 3? Amongst all of the series that we're going to, amongst all of the classes and all of the series that we're going to be taking. So today's class is, of course, as you all know, is just an introduction to Docker, right? Or you can also name it as Docker containerization, whichever name that you want to use it. Okay, so on behalf of my co-founders, Nuruddin and Sheon, I welcome you all to yet another class, for us to talk about Docker and also discuss some of the basic concepts that you need as a DevOps practitioner. Okay, so without wasting much of the time, I will just go ahead to share my screen. I'll just go ahead to share my screen so that at least we can commence as soon as possible. So I'm sharing my screen now. Okay, please let me know when you can see my screen.
We can see it now.
All right. Okay, so so today we're going to be guided. We're going to be guided by this guideline, right? We'll talk about introduction to VMs and containers, Docker installation, Docker file images, containers, and their use cases, Docker files, Docker build, running Docker containers, environmental variables, of course, and some other concepts around Docker networks, Docker volumes. Then lastly, we're going to talk about the optimization technique. Very, very important. Very, very important. Okay, so let us go straight into it. So what you can see on this screen, right? Just before I even start talking about Docker itself, let me just give a little background of how we got here. Because like five or 6 years ago, nobody was talking about Docker, especially in Nigeria, right? Nobody was talking about containerization. Everybody were talking about this beautiful technology called VMs, virtual machines. So let's just start from there. So VM, as we all know, is a virtual machine, right? That is clear. And of course, a VM would always run on top of a physical machine, right? So what that means is that what you can see on the left-hand side here is the use case of a VM. And a VM would always run on a host, right? It will always run on top of a particular virtual or a particular host server. So we can just call this the infrastructure itself. On top of this infrastructure, there's something that we'll call hypervisor. And I'm sure that Sheon actually explained this, when I was taking the Linux class a few weeks ago. So on top of this infrastructure, we have a particular software, right? Or you could also call it a firmware that runs on top of the infrastructure itself. So by the time you buy your server, like you are buying the bare metal server itself, on top of that, you are installing what we call hypervisor, right? And that hypervisor is just a piece of software that helps you to run several virtual machines on the same infrastructure itself. Gone were those days where, when I was still working as a sysadmin, right? We had physical servers. And on this physical server, right? That's when we now start deploying, applications. We can deploy those 2 applications to run on this physical server that you can see. So what happens when we need to run multiple applications? Then it means we have to start buying more servers. Like we need to start buying more servers. And this hardware itself is not a cheap hardware. It's a very expensive hardware. So what the guys at VMware, the solution they now came up with was to just create an hypervisor. So they created an hypervisor, and with this particular hypervisor, you'll be able to install the piece of software on this infrastructure. And with that, you can be able to run your different virtual machines and all. So if you need to run multiple applications, what you just need to do is just to spin up a VM. And within that VM, which is called a virtual machine, right, you can now, install your app, your dependencies, such as your binaries, your libraries, as well as another guest OS. Remember here, there's no guest OS here, within the whole setup itself. So what you have installed on the physical machine itself is called the hypervisor, but not the guest OS. But on top of this hypervisor, you can now install your virtual machines. And then the first thing that you need to do is to now install your guest OS. And your guest OS can be what? Linux. It can be Ubuntu. It can be RHEL. Do you understand? It can be SUSE. It can be Windows 10, Windows 2016, 2019. Whatever it is that you want to install can run on the virtual machine. Then on top of that, you can now install your applications and your binaries. This is clear. But the major issue with this is that there are different, constraints. And that's to say that there's usually high utilization. Let's say, for example, now we have about 20 virtual machines that is running on this particular host, right? It is possible that a particular virtual machine, let's say virtual machine A, is making use of the high CPU or high memory. Of course, because this virtual machine is actually making use of that much resource, it can actually slow down the entire system, right? So another constraint is that the size of the VM could also grow as well. So a VM can go as high as 1 terabyte, as high as 2 terabytes, and what have you. Another constraint with this particular technology is that it takes longer time to boot up. So, for example, let's say there's a maintenance that is going on here, and I need to take down virtual machine A here. By the time I want to boot up, right, it's possible that this guest OS can take as much as 10 minutes for you to just boot up this particular virtual machine, hosting the application itself. So you can now imagine having 200 virtual machines. You can now imagine, doing maintenance for all of those apps. Imagine when you have a downtime, all of those issues, or imagine when your hypervisor itself is having an issue, so to say. Of course, you can do a migration of these VMs to another physical box, but there are instances where your hypervisor itself might just be having some issues, and with that, all your VMs automatically will just go down. And what that means is that business would suffer, because the different applications that your customers call are actually on this particular architecture itself. So this is what most people use today, especially in Nigeria. This is kind of like the technology that most banks use today, where they have several virtual machines. If they need to patch, right? If they need to patch, they have to, they have to patch the virtual machines one after the other. If they need to update that virtual machine, they have to update it one after the other. So all of these issues was what now gave rise to the use of containers. And this is what we have on the right-hand side here. So for container, the architecture is quite similar, but it's different at the same time. So before I actually define what a container is, let's talk about the underlying architecture itself. So what do we have here? Of course, we have the infrastructure, right? We now have the host operating system. In this particular scenario, remember that the OS is embedded inside the virtual machine. But here, the OS has now been abstracted from this virtual machine and is now installed on the infrastructure itself. And then on top of this OS, we have what we call container engine, right? So by the time you install your container engine will now be responsible for spinning up what we call containers. So what are containers? Containers are lightweight software packages that contain all the dependencies required to, execute your software application. If you check the virtual machine that we have here, the virtual machine also has its own application. It has its own binaries, libraries, and the guest OS. But within the container itself, the only thing that the container would need to be able to perform optimally is just your application and its dependencies. So this is a typical interview question where they will ask you that, what is the difference between a virtual machine and a container? Of course, you have tons of differences to be able to explain, right? So moving on. Now, what you have here is called a container engine, which I'm going to talk about here. Now, there's a difference between Docker and container. Please don't mix it up. There's a difference between Docker and container, right? Because I hear people say, okay, a Docker is a container, or a Docker is a container engine. So what is now Docker? Docker is an open source software framework for building, running, and managing containers either on the servers and the cloud. Do you understand? It's just a framework. It's just a software for building, running, and managing containers either on the servers or on the cloud. Now, what is now a container engine? A container engine is any technology that allows you to, isolate applications with their own operating environments. Do you understand? So we can now say that Docker is a type of container engine. Am I making sense? So Docker is a type of container engine. So, and there are different types of container engines that we have today, right? There is, of course, there's Docker, there is Rockets. Let's see, let me just show you. I'm just looking for one that has all of the lists. Let me see this guy. Okay, so you can see them. There is Docker, right? There is IBM WebSphere. There is Red Hat OpenShift. Of course, this is more in tune with orchestration, right? There is LXC. There is also Rockets. I don't know why Rocket is not listed here. So the Rocket is spelled as RKT. RKT. container engine, right? So it's spelled as RKT, but the pronunciation, people usually call it rockets. So you can see RKT is an application container engine developed for modern productive cloud native environments. So there are different types of container engine. And this is another typical interview questions where they will ask you. Right? So you need to mention Docker, rockets, which other ones again? There's LXC and host of other ones. But the most common one that at least people use, and what we're going to be using in this class is Docker itself. Okay, so let's move on. Good. So what are now containers? We've talked about container engine. What is now a container? The real definition of a container is a lightweight software package that contains all of the dependencies required to execute a software application. That's all. So it's a lightweight. That is just the basic difference between a container and virtual machine. Virtual machine is not lightweight because it contains your binaries, your libraries, your dependencies, the guest OS, the application as well. So a virtual machine can go as high as 1 terabyte, can go as high as 2 terabytes. But container does not have all of those constraints. Instead, it contains its dependencies, like the libraries, the packages it needs, and other things that are required for the application to run, right? So that is just a basic introduction of what we have and how we actually got here. And what this means is that within containers, right, you can actually spin up different servers, install your containers, and of course, on top of that, and this is something that we're going to start by next week, where we'll talk about how, if I'm now able to deploy, let's say, another host. I have the infrastructure here, I have the operating system here, I have the container engine here, then I now have several containers living on this host, several containers living on this host itself. Do you understand? Now, how do we now manage all of these containers? Because you can have as high as 2,000 containers. How do you manage it so that when this container goes down, how do you administer it to come back up automatically? And that is where the concept of orchestration comes into play. So an orchestrator like Kubernetes will now be installed to now manage your entire infrastructure. So by the time you now install your cluster, your Kubernetes cluster, the cluster will see all of these hosts. Even if you have 50 hosts, Kubernetes is going to see all of these hosts as one giant machine. So that even if this container goes down, right, Kubernetes is intelligent enough to spin up another container automatically. And guess what? If this entire host goes down, all of these containers, they'll be migrated to another host automatically. So today is not Kubernetes class. By the time we get to Kubernetes class, we'll talk about Kubernetes proper, right? Okay, so next bits, let us go ahead and do some hands-on. So I've actually asked you to install Docker. I hope we'll all have Docker running on our systems right now. Do we have Docker running on our PCs? Or if it's on the cloud that you actually want to make use of Docker, fine and good. But the most important thing is that you need to install Docker. So I shared this link with us yesterday. I think it's docs. Yeah. So I shared this link with us to install Docker on our host. So now, how do we now install Docker itself? Docker can be installed, on your Windows machine. It can be installed on any distro of Linux. It can be installed on the cloud. It can be installed anywhere. right? So I've actually gone ahead to install Docker on my PC. Now, this variant of Docker is called Docker Desktop, right? Docker Desktop, where you could, run your containers, you can run your workload, but it is not advisable to run this in production. It is not advisable to run your Docker workloads, right, within a Docker Desktop for production grade access. So whatever it is they are doing, please don't do this on production. We'll just be using this for the class for today, right? So if you've not installed Docker, please just go ahead to install Docker. So this is one way to install Docker. Another way is to install Docker directly on your Ubuntu OS itself. So if you should go through the instructions, some have actually started installing Docker. Of course, it will tell you the different installation methods. This is the Docker Desktop for Linux, right? And of course, you can just go ahead to install it if you've not installed. So we're not going to talk about the installation because this was already passed through. This was already passed through to us yesterday to install, right? So this is just a process. If you have any issues with installing Docker, please let me know, but it won't be during the class. So you can just follow up. Okay, so let's go ahead. So we've talked about introduction of VMs and containers, Docker installation. So let's move to Docker file, images, and containers. So what is a Docker file? What is a Docker image? And what is a Docker container? Now, all of these are going to be the building blocks for you to be able to run your application. And I'm going to show us a sample demo of what an application looks like, how you are going to run it traditionally, and how you are going to run it within a Docker container. All right, so please follow me. I'm just clean the board a little bit. Okay, so a Docker file, right? Let us paint this scenario. I need to build a house. Okay, so I need to build this fantastic house by iStock, right? So I need to build this fantastic house by of course, this is an image from iStock, right? So what do I need? Like, who are the different parties that are going to be involved in building this house? Of course, I will need an architect, I will need an engineer to design, and of course, give me the specifications needed to build the house. Hello, is anybody saying anything?
No, sorry, I wasn't muted.
Okay. Yeah, cool. So I will need an architect, I will need an engineer or a design engineer to help me build, and then give me the specifications that will be required to build a house. Now, what are the specifications that will be required to build a house? Things around the plan of the house, the materials needed, the things around sand, cement, of course, the quantity needed on how to mix the sand, water, cement, and all of this need to be written within a document, right? They all have documents to be able to highlight all of these processes. Am I right? Do you have engineers in the house?
Yes, you're right.
Good. So that document, see that document as a Docker file, right? So moving on, these documents would have to be interpreted by a contractor. And this is the person that you actually contract the actual building of the house to. Would have to be interpreted by a contractor who then built the house, not according to his own specification, not according to what is seen on the internet, but he's building that house according to the specification in that file. Anything outside that document, is not valid. Do you understand? After a successful project, the house is now finally built according to the specifications. So you can see that house as a Docker image. Do you understand? Now, the last bit is that the owner of the house needs to move inside. He needs to move inside with his family. He needs to move inside with his relatives, right? He will need what? He will need what? Water supply. He will need gas. He will need power. Do you understand? By the time all of these things are running inside the house, it means that the house is ready to be moved into. So you can now see that house as the Docker container. Am I making sense? So whenever you are trying to run your container, you need to have that mindset. What are the three important things that are needed? What are the three important things that are needed? Number one is the Docker file. Number two is the Docker image. And number three is what? The Docker container itself. Very, very common interview question. Differentiates between a Docker file, a Docker image, and a Docker container. So moving on, just like I've said, that document that has all of the specifications, right, which is called a Docker file. These are the building instructions that are needed to build an image. Or you can say that these are the building instructions needed to build the house itself. And of course, it will contain the operations, and what the developer would need to be able to, what the contractor would need to be able to. So all of those instructions, this is how I want my house to be. I need it to have a red paint. I need to have a pool in front. I need this garden, by the side, and what have you. All of this set of instructions will be written inside the Docker file, right? And of course, by the time this house is now fully built, right? By the time it's now fully built this way, it's possible that the pool here does not even have water. It's possible that the house has been fully painted, but maybe there's no gas. Of course, maybe there's no electricity. Of course, it needs to pay the bills and all. Do you understand? All of those processes would need to be in place before the owner of this house can actually move inside the house. By the time he has moved inside and everything is running, then you can now see this as a container itself. So, does anybody have any questions thus far before we move into the practicality of everything I've explained? Because I had to use like 30 minutes to explain the concept of what we need. Does anybody have any question before we move on?
Please, can you explain the Docker image? Thank you.
Yeah, that was what I was about to ask you, the Docker image.
Okay. So, the Docker image, right, is a lightweight, standalone, executable package of a software that includes everything needed to run an application. It's as simple as that. It's a lightweight, standalone, executable package of a software that includes everything needed to run an application, which can be likened to the contractor has finished building this house, right? Let us just see this house as being lightweight, standalone, executable piece of, software that includes everything needed to live in the house. It's as simple as that. So the fact that this house is standing, the fact that there's a pool in front without water, does not necessarily mean that the owner of the house can just enter and just jump into the pool and, just be doing as if he's swimming, or go into the house. Okay, my house is ready. He will get the pot. He will do as if there's gas. He will be cooking and all. What he needs to be able to live comfortable in this house is the water, the gas, the electricity, and all. By the time it has all of these things running, then that is a Docker image. That is a Docker container. But a Docker image is what is needed, right, before you spin up a Docker container, before the final product. So you can see the Docker image as like your semi-final product. But the things that are needed to get that image to start running is what we now call a container. Do you understand? So an image can be as useless as not even using it. An image is very, very useless when you are not really running it, as a container itself. So this is what it means here. Remember, you have a Docker file that has all of the specifications needed to what? Build an image. So let's see this as the image itself. Right? Now this image is just static, but it has everything needed to run. It has, the runtime, the libraries. Remember where we are coming from, where we say that for a container to run, it will need what? The libraries, the dependencies, and the code itself. So the libraries, the dependencies, the code, everything is inside the image. But for this image to now start running, you cannot see it as a static car that is just parked. It's not running, it's just there. So this car can be parked for 10 years. Everybody will, wow, fantastic car, but it will be useless if it's not running. So for it to now start running, right, you will need to start the car for the car to now start running. Of course, the car will now run based on what it has inside this image. So this final product that you're seeing here is what we now call a container. Does that answer? Because if you don't understand this concept, you will be confused. And that is why most of the tutorials that you see today, they will just go ahead, okay, this is how to run a container, this is how to run, but people end up being confused as, okay, what am I even doing? So if you don't understand this concept, you're going to find it very, very difficult. Any other question?
Sorry, can you come from, let's say, an example of, let's say you have an app, let's say you need a Node.js app, and then that app needs to be quote unquote containerized. From what I've learned is that you need a Docker file to do that. So can you explain?
Yes, we'll get into that. We'll get into that shortly. We'll get into that shortly. In fact, that is even the next thing that we're going to do. But I just need to understand this concept so that by the time we're now going to the hands-on, you won't be confused. Okay? Okay, so let's move on. So before we examine what a Docker file looks like, let me show you. I actually uploaded a sample Golang application. So you can actually pull this. You can actually pull this repository. It's public. So you can clone it. Let me just drop the URL here. Remember we talked about Git last week. So just do a Git clone. So let me just send it within. Okay, so just clone this, in your terminal where you have your Docker running. Okay, good. Now, this is an application, right? The developer has, told you that, Ada, we need to run this application as a container itself, right? So let me show you the content of the container. Sorry, let me show you the content of this particular application itself. So yeah, so I've been able to do okay, so everything is up to date. So I've been able to do a Git pull. I'll be able to clone it and I've pulled it. So what you have here is the same thing as what we have on this repo. There's no difference. You see? There's no difference. I just put it in within my ID so that we can just show you what needs to be done. And this is just a sample web application, using Golang. So again, you don't need to really know what this application is actually doing, line by line. Of course, that's the function of the developer to be able to explain what this does. And it is very, very important that you always work with a developer, because the developer would, tell you what you need to do. If there are things that you need to include within your Docker file, you need to work with a developer as you can. So this is our application. This is our web application. Now, what does it do? For those that actually are familiar with Go, so it has two functions, the handler and the main function. And of course, the function of the handler here, the function of this handler is also handle HTTP requests. That's all. So meaning if I should go to my browser and type maybe localhost, and if I type localhost and then I specify the port, is this handler that is going to handle that request that is actually coming in? Do you understand? And then the next one is, of course, the main function. And of course, in Go, there is always an entry point to an application. So this is an entry point. And what this means is that whenever a request is made to the server's URL, right? It's made to the server's URL, it will point you to the handler, this function that is here. It will point you to the function to be able to process it. It's as simple as that. So that is just what this is doing. So the developer has given you this application. What is the next? Like, if you need to do this manually, you need to do what we call a build. You need to build this particular application. I'm not even talking about Docker right now. I'm just talking about manually. And this is what the developer will always do on his PC. He needs to build this particular Golang application, because this is just a source code. It is useless. It's just sitting there. But for us to be able to use this, we need to build it. So in Go, of course, this is also applicable to .NET, is applicable to Node.js, is applicable to anything that you need to do. You must always build that particular application, and there are different processes. So in Go, the first thing that you need to do is to initialize this particular application itself. And the simple command is just go mode init. Then you can just give it any name, maybe daas. So again, you need to initialize it, but this depends on the kind of application you are running. So if you are running, if the developer wants to build a .NET application, right, you need to ask the developer, what are those manual processes that usually take to build your application? The developer will now advise you on all of those manual processes. So let us assume that I'm a DevOps, because I also write Go as well. But let us assume I don't write Go. I'm just a DevOps practitioner. I have spoken with the developer that wrote this application to tell him that what are the processes needed to be able to build this your application. It will now give me all of the steps. The first step they has given me is I need to initialize this particular application itself. If you see this red line, the red line is telling me some things, telling me that, some things are missing, whatever, I need to initialize it. So this command is going to initialize it for me, right? And by the time I do that, there's something that downloaded automatically. It's called a go.mode. This mode means modules. And these are like the modules that are needed for this particular application to run. Immediately when I run this when I run this command, you can see that line disappeared immediately, meaning I have found the module that I'm looking for. You can go ahead. If you have other modules, that are needed to be run within your application, the developer would inform you. So you can still run it manually by typing go mode download. You can see what it's telling me. It's telling me that no module dependencies to download, meaning you are fine. What is the next thing that the developer has told me to do? You can now go ahead and run this application. Simple. And the command is just go run. And then I will point to this file, webform.go. That's all. If I run this, see what will happen. It means it is now listening for requests on what? Port 8080 on my local host system. And what this application is just doing is that it's just going to serve me, a particular web page. It will color it green. I can change this color to anything. It will color it green. And then, of course, I have to specify my name. So let me just show you what I've done here. If I come here and just type localhost port 8080, can you see what is happening? So this, based on the application, it is waiting to collect someone's name. Let me say Ada. Do you understand? That is just what this application is doing. So what I've done now is that I have built this application according to the specification that the developer has advised me to do. It's as simple as that. If I stop this, and let's say I want to change this to blue, right? And let me add some formatting so that this hello that we have here, if I refresh this in now, it will go off because, of course, I've stopped it. So that's hello Ada. Let's say I want to just do a little bit of formatting. I want to change the style. Let me say I want to increase the font size to be 70 pixel. And the color of that hello, I want to change it to pink. Let's say pink.
Sorry, what about the color of the background, the green background? Can it be changed?
Yeah. I would change that as well. So sorry, this size. Right. And close this. So I've changed the background to blue, and the color of the font itself, I've changed it to pink. So let's save this and run it again. So going back to the browser, if I refresh this, you can see it has changed to hello Ada. So let me just change this to capital letter. Sorry. And okay, well, because it won't because of the case sensitivity, it would, okay, yeah, cool. So that is just what we have here, meaning I've already built this particular application. It's as simple as that. Now, if I don't want to do this manual process, because if you are not running within a containerized application, right, what you just do is create a service. Let me just show you how to do that. So I'm just running this, right? Another process will be for me to do a go build, right? And points to the name of the application itself, right? By the time I do a go build this way, it is going to create an executable for me. This is executable, right? And if I should just go to that same folder, yeah, this is the folder here. This is the executable. If I run this executable, can you see? It is actually listening for requests. The same thing, if I go back to my browser and refresh this, can you see that it is still able to serve requests? If I close that executable, where is it? If I close this and refresh, it's gone. So in production, this is how you are going to, now install this .exe. You can now install it as a service on the server, for it to now run conveniently. So that is what you would usually do if you are not running the Docker. Another part is that you can do a go build and then specify like an output. Let's say I want to name it main, right? Then point it to the web form itself. By the time I do a go build this way, it's going to what is this? Okay, sorry. I was pointing to the exe. I need to point to the Go file itself. So it's going to create another main file here. Can you see? So if I should just rename this and add a .exe behind, it will turn to the same executable as this. There's no difference. So I'm just kind of like trying to show you the different building options that you will run if you are manually deploying this application. If you are manually deploying this Go application, right? So we don't want to do this. We now want to Dockerize the entire process. We want to run it as a container. What is the first thing you need to do? You need to what? Create your Docker file. So let's go ahead and create our Docker file. So to create your Docker file, just the Docker file this way. That's all. Press enter. It's going to, create a file called Docker file. And automatically it will change to the icon of Docker. So let me clear this screen and we'll move on. Now, before you start building, remember what we are trying to do is that this is where we are coming from. Please, let's not miss it. This is where we are coming from, right? We need to build this particular application into an image. So the first process of building this into an image is to create your Docker file. That is what we want to do now. Do you understand? Now, a Docker file would always start from what we call a base image. If you need to also build your own image, from scratch, you can actually go ahead. But most times, best practices is, since I am going to be building a Golang application, just like you can see here, I can as well start building from an existing Golang image. And this is an image that they've given to the entire public, that if you need to build your image, you can as well just start building from our image, because our image contains all of the, it contains all of the tools, all of the libraries needed for you to be able to build your application. So, and the first keyword is from, meaning I'm building from an existing image. So I can name this Golang and give it a tag, let's say 1.19. I'm not the one that actually came up with this. If you should go online and search for official Docker images, by the time you go to the Docker official images, the Docker hub rather, can you see? Can you see all of the different tags? So I can as well change this base image. I can as well change it to whatever it is that we have here. I can as well change it to maybe Docker, whatever image tag that we have there. Do you understand? That will be used by, no, sorry, this is Docker. I'm looking for Go. Official Golang. It's confused. Yeah, official Golang image. Exactly. So you can see that this is the Docker official image by Golang. And Golang have said that for me to build an image, I can start building on top of their own image. You can see the different tags that we have, 121, you know, there is, of course, there is 1.1.19, because I've actually used, this is actually the most recent, but you can use any of the tags that you have, but I'm just going to go with this from Golang 1.19. So this is saying that I need to start building my image. So this is the entry point of any image that you want to build.
Good question. Is there an effect if probably you use a very, very old image?
Of course.
For instance, maybe Golang.1.0.
Golang what?
For instance, you're using .1.19. So I'm thinking
Yes.
that .1.0 is an older version to .1.19.
Yes.
Is there any effect using something that's pretty old?
Well, there is no effect, but you should know that what we have in this image itself are the updated tools and the libraries, sorry, needed to be able to run your application. The same way I came here and I remember the first command I did. I had to what? I had to do a go mode init. And that go mode init, if you check it here, it's telling me, see, it gave me this go.19 automatically. I was not the one that actually imputed this. Do you understand? I can as well change this to go 1.20. Do you understand? I can as well change it to whatever it is I like. But because I've been working with Go at least for quite some time now, the most stable version that I've actually been using is this 1.19 because it works with all my applications. And these are examples of some of my applications that you have, you know, like just a couple. So here I use the 1.19. In your own case, you can as well use 1.21. You can as well use any version that you want. But for the sake of this course, we're going to be making use of 1.19. Right. So the next thing is that remember that we're actually building an image. So we are saying that within that image, just see this particular Docker file as being that we are inside the image itself. So I am building from what? Golang 1.19. The next one is I need to define what we call a work directory. Right? Now, to make things easier when we are running the rest of our commands, right? We can create a directory inside the image that we are building. So what this does is that it just instructs Docker to use this particular directory as the default destination of all of the other commands that we're going to be running. So you can just see this as your make directory that you have on Linux. For example, here, mkdir, let's say app, right? The same way I need to do this is the same way we are doing here as well. But to be able to create this particular directory inside the image, I'm not going to run mkdir because, of course, the Docker container image does not understand what mkdir is. But the equivalent command to create a directory, right, inside the Docker image itself is what we call the work dir. So I will now, create a folder, the same app that I just created, within my Linux. So quick question, let me ask, right? What does this do? If I come here and say, if I do this, if I do cd app, what do you think will happen here? Anybody?
You are changing directory. You are changing the directory, the working directory into the app directory.
Exactly. The same thing that is happening here. But remember that what I did here was that I ran two commands. I first created the directory called app, and I had to cd into that particular directory. But if you now want to create it within your Docker file, the work directory is going to do the both process for you. It's going to create this app and then cd into that app for you. It's as simple as that. That is just the function of this work dir/app. Do you understand? Remember where we are coming from. Please don't miss this. We have defined that whatever it is that we want to do, we need our base image is specified here, right? I now created a directory. I can decide to call this Ada. I can decide to call this Femi. I can decide to call it anything, but I'll just leave it as app. Do you understand? Now, the next thing is that we now want to copy our modules. Remember what we did here, where after initializing the Go application itself, right? It created a Go mode for us. We now want to copy this Go mode inside the Docker image itself, right? That's the next process. So what do? We'll just type a copy.
Hello?
Yes. Please go ahead.
I have a question, sir.
Please go ahead.
Okay, maybe go on.
In the place of the working directory, sometimes I see people putting /... So what is the meaning?
Okay, good. So let me ask you a question. We've done Linux, right? We've done the Linux class, right?
Yes.
So question is, what is the difference between CD and CD tilde this way? Do you know the difference?
No.
Okay. Does anybody know the response to this?
I think this one is good.
It's going to the home directory. We are changing directory to the
That's
home
to
directory.
take it to the home directory.
Okay, so question is, what is the difference between the two? Are they different or they are the same?
It's the same.
They are the same.
Good. What is the difference between CD and CD/dot this way? What is the difference?
This one is going to the root and the other one to the home. The CD is to the home. The other one is to the root directory.
Are you sure about that?
Okay, if there is no dots, remove that. Okay, I think that dot is confusing.
No, the other one, this CD dot / means that CD present directory, then maybe there's maybe a file that we're going present directory. Shall anything CD into the present directory?
So, but are there differences between the two? Are there differences between the two?
Yes. Yes.
Let's try it now. We're on the topic now.
CD goes to the home.
So let's try it. CD app, right? I'm inside the app.
Okay.
pwd. I'm outside. CD.
Okay.
So what is the difference?
There's no difference.
Exactly.
Okay, there's no difference.
You understand? There's no difference.
You did not. What if you just do CD dot /?
No, if you
go to the app?
CD, it will go to the home directory.
Okay, if I do CD this way,
do CD dot /.
CD will take you to the home.
Good, to the home directory of the user, right?
Yes.
So let me clear my screen. Then if I do CD
dot /
like this, yes.
Yeah. Yeah.
Okay, it's still the same.
You
It's the same
understand?
thing.
So
It's the same
if
thing.
I do this and I do this.
No, I agree with you.
Sorry, and I do this.
Because I was learning, but they cannot do very fast.
Is there any difference?
Oh, there is no difference.
Exactly. So So Emmanuel, so what you are seeing in other documentation is almost the same concept as this. So maybe what you are seeing in their own documentation is this, right? Hello?
I'm with you, sir.
So what you are seeing in, within the other documentation you are seeing could actually be this.
We name it drugs.
And it's still the same thing.
Okay.
But best practice is saying that just stick to the simple way of, first creating an app and then CD into that particular app itself. And the command to do that for you is this work dir. It's as simple as that.
I have also seen some documentation where it does work dir, work dir /usr/store/app.
It's still the same thing. It's just a folder. Remember, the same way I did this, I can also do mkdir/var/femi.
Yeah.
mkdir/var/femi. The same thing. I can CD into you see, it's still the same thing as saying I want to create an app and I'm calling this Femi, calling this Komike, calling this Kingsley. There's no difference. But I'm saying that for us to be able to keep it simple, let us create this as an app like this. Do you understand?
Yes.
Are we getting this? Or it's confusing?
The concept is well
No, very clear.
Very clear.
Okay. Yeah, good. Emmanuel, are you fine now?
My own question is this: is it that for you to apply this Docker, a developer must give you an already packaged application to work with before you can create the Docker file or build the image or something?
Exactly. It's going to give you the already packaged file. Remember that what we have here, what I did here is I already have my packaged file because
Okay.
I have the modules, I have the dependencies needed, but I've not run this application. Do you understand? So this is what the developer will give you.
Okay, from here now, you will now go
let me
and
even do
create a
this.
Docker file for it.
Let me even do this, right? Let me add it to the repository so that at least you guys can pull it. Git add all here, right? So let me commit it. Right, and let me just push it. The name of my branch here is develop branch. Can you see develop branch? So I'll push it here now so that you guys can also pull it as well. Good. So it should be there now. So if I refresh this repository now, you see what I just pushed 37 seconds ago. So doing this, I'll be pushing it to this particular repository.
Must I have big bucket account before I can push this? Or
No. No. It's a public repository, so you can just clone.
Clone from my Git, from my this thing.
From your system, just type git. Yes, from your system, just type git. The command I pasted within the chat itself. Just type.
So once I type git clone, it will clone this repo to my own.
To your present working directory. So let's move on very fast. So let's go back to our Docker image. So let's go back to our Docker image, right? The question of our Docker image. Now, I've created this folder and I've entered the folder. That is what this work dir is saying. I have created this folder and I have entered it. right? The next thing is we need to now copy the dependencies, the Go modules, because we are kind of like copying it inside the image. We don't want to run it manually. So the command is just copy. What am I copying? I'm copying go.mode into where? The present working directory. Do we understand this part?
That go.mode, is it the name of the package?
It is here. Can you see it
Okay.
here? Remember
Yeah.
that I have already initialized this.
Okay, from the
Created it.
Golang this thing.
Yes. You know what?
Okay.
Let me
Nah,
delete
nah,
it for you. Let me delete it and do it again so that
this is confusing me.
that is
Sorry,
not
my
confusing.
confusion is that
So
one thing
guys,
that
please
telling
let's not take time. This
Okay,
is
this is
the
the beginning now.
this is the raw package,
Okay.
right? This is the raw package. And I'm saying that whatever it is that your developer is going to give to you can be different from Go. It can be .NET, it can be
Okay.
Java, it can be anything. So
Okay.
communicate with your developer on how to be able to initialize your project and how to be able to download the modules. That is the
Okay.
first thing. And that is where collaboration come into play. You are not just running this on your own. You are running this with your developer. The next thing is that because this is Go.
Hello.
Yes.
So I want to ask, is Golang and other apps same command? So if you ask your developer now, if it is maybe .js, are you still going to use the same maybe JS initialize whatever?
No, that was why I
No.
said that. That was why I said that they are different. The process of building a particular language is different. Do you understand? It's different. For example, .NET, right? .NET command is, just type in .NET build, .NET restore, .NET this, .NET that. Go is go run, go build, go test, go this and go that. Java can be Java build, Java test, Java this and Java that. Do you understand? So what I'm doing here are just the processes to be able to build my Golang application.
But sorry, sir, when it comes to Java, I think it's a Marvin install.
I don't know. So that's why you need to ask your developer. You need to work with your developer to be able to get all of those processes. But we can check together, Emmanuel. Let's check together. How to build.
I think we can just go with this one first, and
because I really want everybody to explain, to understand. If this is where we are going to stop today, I am fulfilled. Because if you don't get these concepts, that is why most DevOps practitioners today in their CV, they will just say, okay, I build this, but the fundamentals, they don't understand it. Some of them don't even understand what they are building. Do you get? So let's see an example. So Emmanuel asked about Java, right?
Okay.
Can you see Java's own?
Yeah.
MVN.
Can you see? Good.
Yeah.
Can you see some other, because I'm not a Java developer. What I use is actually Go. But for Java, they have their own processes as well. Do you get? You can see Gradle init. There are some other, let me even see some of the commands. You can see their own run. You can see that the same way we are typing go run. They are typing their own command. Do you understand?
Yeah.
So it differs.
Yes, I
Can
think
you see
also
their own build? Can you see their own build as well? Do you understand?
Yes, sir.
So all of these processes is what you need to collaborate. Again, very important, is what you need to collaborate with your developer. So the thing is that my developers know me. Even if I know the .NET application I will still have to jump on a call. Guys, please, I want to understand how your applications are built so that I can be able to write my Docker image. And some developers can even go ahead to even give you the Docker image for the application. It's that, it can be as granular as that. So let's see for .NET.
Okay.
How to build .NET applications. Okay, so let's go down and see their own. I'm not looking for the commands. Good. What can you see here? Emmanuel, what can you see
Yeah.
here? What can you see
Net
here?
build.
Exactly. What
Yeah.
can you see here for Java?
Java
Gradle.
is different.
Exactly. So you won't say because I am running go build here, you will now say, okay, any application I want to run, I have to
Go
run
build.
go build. It will not work.
Don't work. Sure.
Do you understand?
Yes, sir.
Okay, good. So let's move on. So starting again from scratch, what am I typing for my go? Just take a look at, just be watching this particular left-hand side, right? If I do
But sorry, Dapo. There is a question I still want to ask. Now you are using VS Code to run this. How can I connect my VS Code? Is it when I just call up VS Code, I just type Docker, it will just automatically create Docker files?
No.
Or
No,
there's some configuration I need to do?
Yes, there's some configurations I need to do. So once you actually, because I have Go already installed on my system, that's the first thing I need to do. And that's why I can run all of this Go command. If I should run a .NET build here, it will not work because I don't have .NET installed. Do you understand? So by the time you install your VS Code, just create a folder. After creating a folder, CD into that folder and do a git clone.
Okay.
By the time you do a git clone, you will see this daas.docker because you are cloning from.
Okay, that's what I've tried it. It didn't work. That's why. Okay, no problem.
So please let us move fast. You can actually rewatch the video and just follow. Let's move fast because we still have a lot that we need to cover. So I'm going to reinitialize. So please watch this particular left-hand side because I am not copying and pasting any module. By the time I am initializing this project, is going to create automatically. So go mode init, let's say daas class. Can you see? It has created this go mode file for me. So if I now need to run this thing, I'll just do just like we did, go run, the web form, just like we have here, and it will run. Do you get? It's as simple as that because of this specification that we have for port 8080, which is here. Where is it again? Localhost 8080. So if I pass Emmanuel here, it's going to echo Emmanuel based on the code base. So your own code can be a web form, it can be
anything.
It can be anything. Do you understand? So it's as simple as this. So I'm going to stop this now and let's go back to our Docker file. Remember, this go mode, I am copying it inside what? The Docker image. So this, remember that I am already inside the /app.
The /app, yeah.
Good. So whatever it is I'm doing, I am doing it inside /app. So if I do a copy go mode and I specify this, it is going to, I'm saying that I should copy inside the present working directory. So it will copy this go mode inside what? /app folder.
/app, okay.
Can we move on?
Yes.
Can we move on?
Yes, we can.
Good. Then remember that command that I ran here to be able to download. Let me clear this screen. Remember the command I ran here to download other modules. I ran go mode download. Right? And then it told me what? No module dependencies to download because I've already downloaded all my modules. So the same thing here, assuming I have other modules, right, that I need to run within my application, I can just run it here as well. I can now say, okay, after you have copied the go mode, run go mode download.
Okay.
Right? Are we fine? Are we good? Hello?
We're good.
Are we good?
I'm not good.
Good.
No.
Why are you running? Why did you, that last command is what I don't understand.
But I ran it here. See, guys, let me go back to the basics again.
It's okay.
Just imagine that I am not doing Docker. Like Docker is not even in the mix of anything I'm doing. I need to deploy this application manually. The developer has given me some set of commands to be able to successfully build this application. And the command that the developer has given me is, he has given me what? Go mode init to initialize, go mode download, go run, and what? Go build. It was the developer that gave me all of this. And what is the function of the go mode init? The go mode init is to what? Initialize this project.
The project.
Good.
Okay.
The go mode download is to download all the dependencies. Remember where we are coming from. That for us to be able to run a container, what do we need?
We need the dependencies and the...
Exactly. So I need to download those dependencies. That is what I am doing here.
Okay.
But because I don't have, because this code itself, this code base is a very small code. I don't have, many dependencies as in there. It's not telling me that Mr. Dapo, you don't need to download any other.
Okay. So what you are running on your terminal down is what you are repeating up in that Docker image file.
Exactly.
Okay, that's the conclusion.
Exactly. So whatever it is that I'm running here manually is what I am following within this Docker file, so that it won't appear like I am doing anything. Okay, Reese, ask your question.
I'm sorry. I'm sorry for taking you guys back.
No, it's fine.
I'm unable to run the go command. I'm getting the distance that go is not recognized and all that.
That was why I said I have go installed on my system here, right? Okay. I can run the go command. So if you need to do that, just follow this tutorial on how to install install Go on Windows. What are you using?
Windows 11.
Windows 11. Straightforward.
Okay, thank you very much. I'll do that.
Can you see?
Yes.
Straightforward. So please do that. Okay. Any other question? Do we all understand these bits?
Yeah, I think it's clear now. Yeah, it's very clear.
Yeah, it's clear now.
Depending on the application you are running on your Docker file, it might not be, our own might not be Go. Depending on what the developers specify, that's what we use to build the Docker image, right?
Exactly. Yes.
Okay.
Hello, Ada. Are you fine now?
Yes, I'm fine.
Oh, fantastic. Okay, so let's go on. Okay, you know what? Let's take 2 minutes stretch. And then
before you go, can you just please copy all these commands and just paste it on the chat? Thank you.
Okay, all right.
Screenshot. I think it's screenshot. Okay.
I don't need a screenshot. I want to copy and go with the flow immediately.
Oh, you know what? Can you access the repository?
Screenshot it yourself now. Okay.
Can you access the repository?
If you even access the repo, you see it there.
Access the repository. Let me just push again so that you can have this. But I've pasted it within this chat.
I was able to access the repository.
Exactly. Fantastic. Fantastic. So guys, let's take 2 minutes break and come back. Sorry, this is 1:24. Let's come back by 1:27.
Okay.
Thank you.
Okay. Are we good now? Can we go on?
Yes, boss, we can.
All right. So just a little bit of recap. My web form, I have Go installed on my PC. I have Go installed on my PC, and I'm able to run all the Go commands. The same process within the Docker file. For me to, for a Docker image to be produced, I have to sort of install Go as well. Just the same way I have Go installed on my PC. So the equivalent of installing Go on the image, within the image itself for the container to run, is by specifying this from. Meaning I am working from this Golang 1.19 is equivalent to saying that I am going to install Go on my PC. But because I want to run this within the image, I am giving it everything it needs. And that is what this from is doing. You must always have a base image. Always.
Okay.
Right? The second bit is...
And it must be online, Abi? From you are pointing into a repo online.
So I will come to that. I will actually come to that because you can actually have images running within your environment. We'll just point to it.
That quality question, and just to comment, your VS can this are running. Does it have IntelliSense for Go? That
Yes,
also
it
helps.
does. Yes,
that
it
also helps. So as you run, as you put in, you don't even need to remember all the commands. You just remember few commands as you type in, similar to what you do for Linux and also for PowerShell. As you run commands, it's able to sense what you're trying to run, or it brings up other commands relating to what likely you think you want to run. So that will also help you.
Yes. So the same way, if you're writing a Go command there, you can actually see the IntelliSense that shows exactly what I'm about. Yes. So you can just specify, if I should run this, it's going to help me to do whatever it is I want to do. And HTTP, can you see the IntelliSense coming up almost immediately? Yeah. So I will just close this as well. All right. So let's go back to our Go, our Docker file. Then I've created a work_dir/app. And what this work_dir is doing is that it's doing two things. It is creating this app and is now seeding into it. That is what this line 3 is doing. Line 5 is I'm copying my modules and my dependencies inside this /app, because presently this place is just like saying, if I should do my pwd here, right? This is going to give me maybe /home/ maybe darkmore /app. This is what after this line, right? This is what this is going to be. Meaning I am, whatever it is I'm doing after line 3 is inside this. Exactly. It's as simple as that. So line 5, I am now copying this Go mode inside this /app. And that is what this is doing. Meaning copy the Go mode inside the what? Present working directory.
Now this Go mode, is it something you're downloading into the Docker image?
Remember that this,
copying it from?
good. Remember that this directory, see, this particular directory, you have to have your Docker file in the same directory as where you have your Go mode.
Okay.
If you have it in another place, if you have it in another space, just specify the parts, either the absolute parts or the relative parts. Do you understand?
Now, I remember that when we started, Go mode was not there. Well, it was when you were now trying to build this manually. You have to initialize Go in this folder, in that's the Docker folder that the Go mode module showed up. Now in the Docker environment,
good.
Do we have to initialize it physically first before we go into Docker environment?
Good question. Good question. Remember when I started, I said the webform.go itself, right? You would have been given, very important, you would have been given the package that you need. And that package, of course, the developer would have given you the go.mode. Do you understand?
Yeah.
Good. So it means that on the developer's end, it would have run the go mode init. It would just upload the remaining to Bitbucket or GitHub for you as a DevOps practitioner to just complete the work. Do you understand?
Because for instance, when you give us this initially, go mode was not there. Well, I'm looking at the LS of what I cloned. Go mode was not there. It was later on when you initialize it manually. You now pushed it back to.
Yes. So go mode was not there. Go mode was not there because. Okay, let me just delete it again because I really need you guys to understand this thing. So see.
No, I understand it. Don't delete it. I understand it. But what I'm saying is that so the developer would also give you this go mode.
Yes.
Exactly. So.
Yes. The developer would have actually given you the go mode, or even if the developer does not give you the go mode, and then it just gave you this webform.go, right? You just have to, since you know that it's go, just do your go mode init. By the time you do your go mode init, your go mode is going to be there automatically. Let me show you an example of projects that I've worked on. Let me see. This guy. Can you see an example of a go mode that is here? It is telling me that I have been able to download all your requirements based on your source code that you have. So this is just my source code. So based on all of this, by the time I run my go mode init, so this is just the source file. By the time I run the go mode init, go mode is going to create this and as well add all of the dependencies I need. You can see this required here. Do you understand? Do you understand? So by the time I do this, the next thing is, remember that we are Dockerizing this thing. We don't want to be running this thing manually. We now have to copy the go mode inside our image.
What's the difference between Docker file and Docker image? Are they the same thing?
I've explained this.
No, they are not.
Okay.
So
let me explain this. Lawrence, let me make it clear like this for you. So when you talk of Docker file and Docker image, so just imagine your Google Chrome. Imagine your Google Chrome, and let me not even use Google Chrome. Okay, yeah, just let me use something you're very familiar with. You deploy patches to ATM. So imagine your batch file that you use to deploy your patch. So before you deploy that patch, you have to download the file, isn't it? You have to download the file you want to run on your ATM. That file you're downloading, see it as your image, your Docker image. The script you want to run, the script is the one that will control that patch and say, okay, go and install on this system, apply yourself, restart, and everything. Everything about restarting, installation, and everything is done from the end of your script, isn't it? So that your script is your Docker file. So it takes all the command, everything you want your image to do, as soon as it comes to the environment, you put all those commands on your Docker file. So the image is what everything about your dependencies and everything has been put into your image. Is it clear to you now? So just imagine that way that you have a script and you have a patch file you need to install on the system.
It's very clear.
So you cannot see that Docker image as the instructions. All of these things that we're typing here are just instructions. And they must be inside a file. That is why we have a Docker file here. Because it is these instructions, remember where we are coming from, that we need to build a house. The plan, how to be able to mix the cement, it can be likened to what we are doing here. You understand? So we are writing all of the instructions to now build the image. So just see that image as the house. So Docker file are the building instructions, right, needed to build an image, which we'll get to. Any other question? So please, let's move on. So right. So we have done what now? We have copied the good mode into the present working directory. Then, of course, this same command that I ran, I can also run that inside the image. And the command does what? Run, go mode, download, right? What is the next thing? I need to copy my source code. So copy my source code inside the image itself. So my source code would always end with a .go. If it's for .NET, it would always run with the what is it called now? It will always run with the extension for .NET. It's for Java, it will always run it. And if you want to copy everything, right? Or if you want to copy maybe like some specific files of your application, you can just specify it by typing star, meaning everything that ends with .go, I need to copy it to this same present working directory. So it means that it is going to copy this web form inside the image. So that is what this is doing, right? Are we good? Do we understand this bit now? Okay. Now, the next thing, remember that after I did this, I did a run build, a go build the web app for it to be able to build the .exe file.
Yeah.
So this is what I did, right? Can you see the .exe here?
Yes. Yes.
Good. So this same bit, I can also do this way. Go build, point it to say that I need to rename that build, right? I need to rename it to, let's say, main. And what am I building it from? I'm building it from my web app, for my webform.go. If I should do this as well, I'm going to create a main. So this and this are still the same thing. This is just an executable. This is also an executable, but it can be used for any platform. Do you understand? Okay. I cannot carry this webform.exe and say I want to take it to my Linux and it will not work. Do you understand? It won't work. I need to look for something that is compatible to run on any platform. And that is where this, by just specifying the output of main, right, is going to create it here automatically. So the same process here. So let me delete the main. Let me delete it .exe as well. So the same process here. I will now have to do a run, go, build, -o. Then point it to, I don't want it to be inside this app directory. I can point it to the root directory this way. Do you understand? I can also point it to Femi, point it to any folder, point it to Tomiwa, anywhere I need to point it to, but I want to point it to this /main this way. Do we all understand?
Yeah.
So this is more like saying cd this way, print working directory, make mkdir main. Can you see this main that is here? Right? I have pointed it to the root directory. That is what this is also doing as well. So I pointed the main. Remember that when I actually ran this, right, it created within the same directory.
Yeah.
I can actually point to say that instead of creating it within the same directory, take it to the root.
Root directory.
Yes. So that's what this is doing, right? Then within our application, the next thing now is what? I need this particular Docker image to listen on port 8080. So I'll just go back to my Docker file and type a keyword called expose the port 8080. So if I have within the application itself, if I have 1000 here, but that's 1000 here.
1000.
Do you understand? So I'll return this back to 8080 and specify that expose this particular container. By the time you start running, expose it to what port? 8080.
Okay, sir. In a scenario where you have two ports, how will it do this?
Where you have what?
2 ports running. How will it do this?
If you have 2 ports running, okay, so let me just explain that concept using a particular diagram. So if you have like a Docker container here that is exposing port 8080, you have another Docker container here that is exposing the same port 8080, right? There won't be conflict because by the time you run this particular image, remember that we're still building that image. By the time we run that image, right, we can now specify the external ports that users can now be connecting to. So we can now say, okay, fine, this image is running inside the container as what? Port 8080. If I need to run this image, I can either still point the external port, which I'm going to talk about, point the external port to port 8080, or to be able to avoid conflict, point it to a different port. So this can now be likened to say the external port is going to be port 7070, directing traffic to the internal port on the Docker image, port 8080. Right? For this other one, this can be 7071, right? For this guy, and it can be pointing to the same port 8080. There won't be conflicts. But you cannot do this. Even if you do port 8080, it's still fine, it will still work. But you cannot come here and still change this to port 8080. It will not even run. This second one will not run because there's a conflict already externally. But internally, you can have the same ports internally. Do you understand?
Yes, yes.
Okay, so let's go ahead. Someone is asking, please, how do we get a Docker file? Because my clone didn't have. Yes, I've not pushed to the remote branch. Oluchuku. I'll do that after now. So let us continue with this. We're almost done with the creation of the Docker image itself. Okay, so the last part now is, which is very, very important. The last part now is that by the time I have finished giving the Docker image all of these instructions, right? I will now say, okay, how do I now run this main file that is here? How do I run the main file? Remember, it's just like saying doing go run main. If I should do this, it's going to run that application for me. So the same thing here, we need to specify how to be able to now run the main file that we've actually that we've built here. Is it making sense? Or we are confused?
Yes. Yes.
So this here, go build, is the same thing as what we have here that I'm running manually on my system, right? Remember that if I should run this go build, it's going to create this main file. Let me just run it again so that this is manually, it has created this main file. So what I just did here is the same thing as what we are specifying within the content, within the image, right? We have exposed the port 8080. And then the next thing now is now to do what? Go run. So how do we now specify? You just have to type this command, cmd, and you can see the IntelliSense that Sean was talking about. It is already telling you that whatever must be inside this command must be an executable. And remember that what we actually created here, main here, is already an executable. So we're now saying that by the time we want to run this image as a container, we need to run the executable.
Okay.
So click on this and just specify the executable, which is what this main here.
Okay.
That is all. that is everything about how to be able to build this Docker file. You can see that
But
there's no magic.
You said that main, what's different between this main and the other one? You said this one, you can use it anywhere, right?
So
why the executable can only be used?
So this one here, so remember, this main that is here, this main that I created here, let me just go to it. Revealing File Explorer. Look at it here. Can you see the main here? It can be run, like it can be used anywhere.
It's just a file.
For our use case, exactly. But for our use case, we're actually using it within a Docker container. So if I want to use it on my system, I will just change this thing to a format, because if I run this thing manually, see, it doesn't understand what is happening.
It won't run, yeah.
Yeah, so I can just change this to what? .exe. Do you understand? And when I run this, it understands this because it is running presently. And if I go to my browser and do that same port 8080 here.
You have you put main .exe.
Oh, sorry, because I was wondering why it wasn't running. So let me rename it. Thank you. So if I double click on it again, right, and then go back.
It has to be running before you can call it up on your local host.
Yes. Have I changed the port? Something is wrong. Let's see.
Looks
I think
like
it's 1000.
Looks like you have to access email.
So what is wrong? Okay. So it's not even. Okay, let me stop this main.exe.
Maybe it's not running.
Let's do it again.
Okay.
Let me just run. Let me just run it from the terminal this way. Do we have anything running in the background? So why is this not running all of a sudden? 1 minute, please. Okay. I didn't save this file. So it was using the initial stuff that was there, because I think I changed it to 8081 or 1000 when I was. So let's run this thing again and see. Okay. So do you understand what happened? I changed when I was making some
you
illustrations. I changed the port and saved. So I didn't change it back to port 88. So we can run the main file again. So it's going to overwrite what was here.
Okay.
And go back to that folder. So we can delete this. This is not needed. Then change the extension to .exe. So it is expected that when we run this and go back to our browser, remember that we've stopped the running, the one that we have here. So when we go back to our browser, it should work. So that's because it is running here. So if I type Lawrence, it's still the same thing. Right? So if I stop this, it should quit. It shouldn't even run again. So
this time around, it's running as a service.
Exactly. You get the logic. So the same thing here, we now have to point it within the Docker file that this is your main file that you should do.
Okay.
All right. So after we've gotten to this point, the next thing that we now have to do is now to build. Remember what we're typing here, where we're typing, go build this and this. The same thing that we have to do for this image. So this image is set. The command that we now have to type is what? Docker build.
Okay.
Right?
Okay.
And specify where the Docker file is running. Remember that we are still here. We are still here, print working directory on my system. If I should type ls, this is the Docker file here. The Docker file is running inside the same present working directory. So the command is Docker. I want to build that image, right? But where do I need to get the Docker file from? I will now say get it here. And that is what this dot is doing. Get it in this present working directory. But if I should do this, it will run, but it's not best practice. What I have to do is to name the image. I'm saying that build this particular application into an image, and then the name of the image should be, let's say, Lawrence, right? And how do I specify the naming convention? I will just put a tag in front of this, meaning build my image. Where can I get the Docker file from? I can get it inside this same working directory, inside the present working directory. That's what this dot is doing. But I don't want to build it. I want to name that image. And what is the command to name, in Docker? Is just to apply this tag, dash tag Lawrence. It's as simple as that. So if I press enter this way to start building, can you see it is already cooking the meal? It is following. Okay, so there is a okay. Can you guys see the mistake?
Okay, there is a it's like it's now running what we have in our Docker file now, line by line.
Exactly. But can anybody identify what the mistake is? Because it's stopped.
That run go mode, that's where it stopped at line 7.
Is not supposed to be there.
It stopped at line 7.
Exactly. So I will just remove that E.
Okay.
And save it. You can see that whatever it is that we're doing is not magic.
How you save it? Is it Ctrl S?
Yes, Ctrl S.
Okay.
Then I will run it again.
Can I see the last command, please? The CMD, the one at the bottom after expose 88.
Yeah. Can you see it? So it has finished. It has finished, building it. It has finished cooking the meals for me. Right. So the next thing is that how do I now view the image? So if you are using a Docker desktop, automatically you will see it here. Do you understand? It created 0 seconds ago. If you refresh it, it created what, 30 seconds ago. So this is Lawrence. And the tag is what? Latest, meaning this is actually the latest image. I can also do something like this. I can also type Docker image ls to view the images that were just created. Can you see? Lawrence, tag is latest. This is the image ID created, and then the size. Now, this size is too huge. It is large. So we're going to talk about the best practice on how to be able to reduce the size, because this is actually large, and we'll discuss that. So let's create another image and call it Ada. I don't know why I like Ada's name. I'll call it Ada. And then tag it, but this time around.
I like it.
Okay. But this time around, right, we are going to give it a version number. So we say Ada version 1, and then build it again.
Okay.
Can you see that can you see that when I ran the first command, it took like maybe like I think a minute or two. But when I ran this second one, because I am building the same Docker image, right? Docker works with the concept of caching. It will check. It will check that, okay, this particular image hasn't been built before. If it has been built and nothing has changed, I will just use the cache for it to be able to make it faster. So let us go back and check our, can you see Ada here? Now, what can you see under this tag?
Okay.
Version 1, and this is going to help you for versioning processes. So let's say I have now made a modification to this particular port. Let's say I've changed the port to what? Port 8081. I save it, and then I want to build. So this is going to go to what? Version 2, because this is another version. Then I can now build it in this way. Right? So Docker image ls. You can see Lawrence, the first one, Ada version 1. This is the one that has what? Port 8080. And this is the one that has what? Port 8081. So this is how you build your Docker image. It's as simple as that. So how do I delete the Docker image? So Docker image ls as well. So if you are using your Docker desktop, you can just come here and delete. Delete forever. It's gone. Delete, it's gone. But if I want to delete on the terminal, let me do my Docker image ls again. Right? So I can type Docker remove image. That is what that RMI stands for. Docker remove image. Then what is the name of the image? So I can now specify the image ID this way, sorry. I can now specify the image ID, right? Or specify the name of the repository itself called Lawrence. And what? Latest. So if I don't specify the tag, by default, it would choose latest. But if I specify something else here, it's going to show an error. No such image. So, but if I don't specify anything here, it would remove Lawrence and Docker image ls is gone. So let's build it again.
Nothing here.
So Ada version 1, but let me take this thing back to 8081. 8080 rather. So I'll save this and build Ada version 1. Or instead of building Ada version 1, let's give it maybe daas_Ada and tag it this way and build it. All right, so let me clear my screen and do a Docker image ls. So what will happen if I do this? Docker remove image daas. Can someone tell me what will happen here? Is it going to run?
Yes, it will.
Are you sure?
Yes.
Are you sure?
Yes, it will, because
let's try it. Let's try it. It didn't run. So why didn't it run?
Because
you specify the name very well.
No.
Version 1.
The tag is latest, but the tag is meant to be version 1.
Because if we don't put the tag, it's going to default.
Exactly. Because, do you understand? If you don't put the tag there, it's going to default to latest. But we don't have daas_Ada latest there. We have only version 1. Do you understand?
Yeah.
Okay.
Do you guys understand?
Yes.
Yes.
So you lost me at the point of Docker build.
Okay, please ask your question.
Yes, sir. On the terminal, you were typing go build this -0 and then you put /webform.go. But here in the Docker file, you're not putting the webform.go. Why?
Okay. So the reason why I'm not putting the webform.go is that here on line 11, if I do a go build -o dash, so automatically it is picking this webform.go. So you cannot see it like saying it is doing this automatically for me. Web form.go under the hood. Because Go would go and fetch the Go file itself that I need to build. But guess what? If I have multiple Go files here, and I want to build a specific application, I would now have to specify, the file to be able to use here. So it's going to be the same way we are doing here.
Okay.
Same way we are doing go build -o, right? Main, right? And I'm specifying the webform.go here. Do you understand? But if I don't specify webform.go, see what will happen? It will still build because it is only one Go file that is here. So that is what is happening here. So what we have here is the same thing as what we have here. Do you understand?
Okay, yes, makes sense.
Exactly. So, but if you have multiple Go files, you need to specify it the way I specified here. So let's say there's another one called maybe backend form.go. I'll just specify, and I'll come here within my my run command to specify that alone. But because of course this is just a demo, it would only pick the default Go that we've already copied here. Remember that line 9 has already copied the Go file, right? So by the time I run this, it would run the Go file that is there by default. Do you understand the concept?
So you lost me at the point of.
Yeah. I would want to ask a question too.
Ask.
Okay.
Oh yeah, ask.
Okay, so instead of doing this, okay. I wanted to say, couldn't we have said copy everything inside the inside this folder and send to?
Exactly, we can still do that.
But does it mean the .gitignore and other files will go with it?
Exactly.
Okay.
Exactly. So there's another concept, although it's inside your assignment. That is why I don't want to mention it. There's a file called Docker ignore. So if I create a Docker ignore here, Docker ignore. Sorry, yeah. Is it docker.ignore? Is it Docker ignore? Let me see.
No, Docker ignore.
Docker ignore.
Okay, Docker ignore. Thank you, Jared. Exactly. So by the time you create a file called .docker ignore, it's still the same thing as what you have as git ignore, meaning whatever it is that you want to push to your repository, don't push anything that is inside this git ignore file. The same thing for Docker ignore as well. Whenever I want to what is it called now? Whenever I want to build my application, I cannot specify that. Say, look, don't copy readme .md. Don't copy
git ignore.
Yes. Don't
And
copy what? Git ignore. Like that.
Okay.
Don't copy with that is, but that one is only applicable if I am copying everything.
Okay.
You understand? So if I'm copying everything, the first place I is going to go and see is that do you have any Docker ignore file? So it will now go and check inside the Docker ignore. Okay, master has said I should not copy readme. Yeah, I said I should not copy this. I should not copy that. So I won't copy it. The remaining files, I will copy it. But because here, provided specify that copy only .go. So that is why it's not copying the other ones, it ignore and what have you. Do you understand?
Yes, I do.
Okay, good. So
Please, you lost me at the point of building, because when I ran the same build command on my server, it gave me an error, said build an image from a Docker file.
Sorry, what's the error that I gave to you?
Docker build requires exactly one argument. See Docker help build an image from a Docker file.
Okay, so do you have your Docker file in the same directory?
Yes, I do.
Because if you don't have your Docker file inside that directory, it will not build.
It's there. I'm inside the directory. I have the Docker file in there.
Are you sure that your Docker file is spelled correctly?
Yes, sir, sometimes I know that it's capital letter D.
No.
That's a problem.
No, it's small letter.
Small letter. Docker file. If you should do
one word.
Okay, good. If you do a PWD, right? What do you, okay, sorry. If you do that LS, can you see your Docker file in there?
Yes, I'm seeing my Docker file in there. I just have readme Docker file and then the web go.
Okay. So what command are you typing?
Type the same command, build, yes. Docker build --tag, give it a name.
Okay. Then
V1.
Okay. Space full stop.
Oh, space full stop.
Okay, sir. Okay. I have a.
All right, that's working now. Thanks.
Okay, it's working now, right? Okay.
Yeah.
All right. Emmanuel, answer your question.
Yes. Like what I actually have experienced when running my Jenkins. Sorry for bringing Jenkins into this, because Docker was included. I write a Docker file and I push it to GitHub. When running my Jenkins CI and CD pipeline, I couldn't find Jenkins. It's telling me there is no Docker file in this repository, something like that. So what could be the issue?
So the thing is that just like the question that the last person asked, right? If your terminal cannot find a Docker file, it will not work. So maybe the context that you told Jenkins to go and look for a Docker file, maybe it is wrong. Do you understand? So you need to properly specify where your Docker file is. That is the only source of truth. If it cannot find it, it will not run. There's no magic about it. But if it can find it and it's saying that it can't find it, of course, you should know that there's an issue. I need to troubleshoot it by properly specifying the context. The context in the CI/CD world is, where do I have the Docker file running? Specify the context. Say, okay, it is running in this particular directory. Go and look for it. Say, it's as simple as that. So we need to check that, right, Emmanuel?
Sir.
Okay, good. So Docker image ls. Let's go ahead. I can see that I spelled daas_ada wrongly. How do I correct that? The same tag, Docker, but instead of putting a -- tag here, I will just specify tag. So you only use a -- tag when you are creating an image. But if you have the image already, you just put tag, Docker tag. Now, Docker tag is saying that I want to rename this. I want to rename this image, right? What is the tag? Version 1. What am I renaming it to? I want to rename it to maybe daas_ima, right? And what tag this time around? Maybe the same, version 1. So Docker image ls. Can you see what has happened? It created another image of this. You can see that the image ID is the same thing. And this is what is going to help you. You can have like 2 million images. And those 2 million images can just be from one particular image itself. So your image ID is the source of truth. So the name can be disguising. but this is the source of truth whenever you're working with Docker images. Do you understand? So it has created this and we're good to go. Now, the next thing is that all of these images are saving inside my local repository. What if I want to share this image with Ima and Ada? I can now push it to what we call a remote repository or a container repository itself. Do you understand? And a popular repository that most people use is called Docker Hub. So Docker Hub is like a hosted repository service provided by Docker themselves for sharing container images. So how do you do it? This is my own Docker Hub, where I can push images to and render it either public or private. If it's public, anybody can be able to pull that particular image itself. So part of your assignment, which you are going to give, is that you are going to create your what is it called now? Your group's Docker Hub, and going forward, all of the images will be pushed to this place, and then you need to make it public so that by the time we are doing our presentation, you are not the one that is going to be presenting. Another person is going to pull your image and run what it is that you have set up inside your remote repository. So the assignment is going to be very, very specific on what to do. So it's going to be a very, very extensive project, which would make you to think. Please don't use, what is it called? Don't use any of the solutions online like ChatGPT, because it's going to give you the answer. So please don't use that. Just ensure that you troubleshoot this thing on your own. Because if you use ChatGPT, I will know. Do you understand? So let us push that image, because right now, Ima and Ada they can't use this particular image because it is on my local repository. So what do I need to do? I need to rename that image to resemble the address of my public repository so that I can be able to push to my Docker Hub. So this is what I'm saying here. You can see what I have here. This is my my username. This is my account, my username, Babalola05. You can see that all of the images that are here, Babalola05 is always in front. So what I will do is this. I'll come back to my terminal. I need to push this thing. I'll come back and do a Docker tag. So let's say I want to push this daas', right? What version? Version 1. I'm pushing it to Babalola05. It needs to tally with what you have on your public repository, Babalola05, right? So you are doing this, Babalola05. Then it can now carry that your daas_ima. It can be anything actually. Maybe daas_anything, but let's not confuse ourselves. Let us still use the same name, Ima, right? What version do I want? Maybe I can still use version 1. So I tag it this way, Docker image ls. Can you see? It's already tagged. The next thing is now to push it. So Docker push. I will now do a Docker push and just name this particular repository. So by the time I run this, it's going to push this image to my remote repository. So, but before doing that, you need to log on to your repository from your terminal. So how do you do that? You just say, I want to log on to my remote repository. Command is Docker login. My username -u, BABULAR05. It will ask me for my password. I will type my password. And let's see if it's going to log in. You can see I've logged in. The next thing I have to do is just what? Docker push. What am I pushing? I am pushing this. I'm pushing it to my remote repository. And what is the tag? Version 1. So let's see. So it might take a while because look at the size. The size is 1.7 gig and it's not best practice. So, which if we have time, I will show you guys how to be able to optimize this particular image, because this is the secret of what most DevOps practitioners do not know. They will just say, okay, oh yes, I've built this. And remember the principle that we're talking about Docker images, Docker container. Docker container must be what? They must be light. Very, very light. Like your Docker container should be less than 100 meg. If 100 meg is even too much, your container should be maybe like 50 meg or 20 meg, sometimes 2 meg. So that by the time you start running this thing within your Kubernetes, everything is going to be lightweight. But right now, look at the size. Size is 1.7 gig. What do? I will show you what to do. So you can see.
If you use Alpine Linux, is it best practice?
So we'll come to that. So you can see it has pushed. So let's check. Let me refresh this. Can you see it here? You can see that I did not create anything before now. I just pushed and then it created by itself. So, but if I need to make it maybe private, I can just come here and change it to private here.
Okay.
Come here and change it to private. Where do I even change to private again? Let me see. Well, assignment, that would be an assignment for you. I know I've changed this thing to private. These other ones, this was like over a year ago. I can't even figure out because I don't even use this. So figure out how to be able to change this to private. So let's move on. So that is that about pushing to the Docker remote, the Docker. Now, what are some examples of remote repositories that we have? We have what? Docker Hub, there's JFrog, there's container registry, there's Azure container registry. So the container registry by Google Cloud, Azure container registry, of course, by Azure. Then the one for AWS is called what? Does anybody know?
Something ECR.
ECR.
So what's the full meaning of the ECR?
Elastic Container Registry.
Good. So these are common interview questions. Mention 3 popular repositories that you know. You mention what? Docker Hub, ECR, JFrog. Simple things, right? So last bit here that we're going to do is now. We now have the image. You can see that the image is just running. It's just here, right? It is not doing anything. So you can now liken this thing to that car that is parked. It's just here. It can be here for like 1 million years. It will be very useless. But we now need to run our container, run the container of this. How do we do that? Right? The command to do that is just want to do a Docker run. So just see this run as saying I'm trying to start my car. And I'm trying to start my car. So that is what this run is doing. Docker run, right? Give it a name. Let's name it Ada container, right? -p, specify the port that this container, remember where we are coming from, 8080 is the internal port. So please don't get confused. This expose is the internal port of your application, which is what we have defined within our web form here. So you can see the journey. The developer has already defined the port that's going to be listened to, right? We have defined within our Docker file that this is the port that the developer has defined. The next thing now is that we can now specify the port itself that users are going to be calling by the time they want to connect to this externally. The same way we are calling what port 8080. So we're not defining that, okay, what port are they going to be calling by the time they want to access this particular container. It can be any port. I can port this 1000. But the most important thing is that it must now make reference to the internal ports that has been defined here. This is very, very important, right? And what is now the next thing? The name of the content, the name of the image. So you can see that we are running a container of an image. So I will now define the image here. And what's the tag version 1. So if I press enter this way, it's running. Remember the concept of this thing. Remember the concept of when we did this as well. Remember this concept. Can you see that this one too is running locally on my system? It is running locally, meaning I am ready to accept requests. This same concept is what is happening here. I am ready to accept a request, within the Docker container. So let's try it. So 1000, we'll just come here and type 1000. Let's see if it would work. Can you see? Do you understand? So if I come here and type Dapo, can you see that it is working? So this is a concept of the Docker containerization. So you have containerized the entire application. You have containerized this particular application that I've seen here. It is now running within your container this way. But I don't want it to hang because I can't do any other thing. See, I'm pressing enter. I can't do any other thing. I can now cancel this. Let me refresh again and see if we'll see it there. We won't see it because we have already canceled, we have stopped the container. So how do we now make it to be, to be persistent? What we don't need to do is to make it in a detached mode, meaning detach from this console and run so that I can do other things. And the command to just type is just -d. That's all. I'm running it in detached mode. So if I press enter now, okay, good. So you can see an error here. It's saying that the container name at that container is already in use by another container. You have to remove that container to be able to reuse them. So that now brings us to, let me clear my screen and see. So that now brings us to, the different Docker container commands. So if I do Docker container lists, can you see? It's saying that there is no container that is running. So why can't I run this command? Why can't I run this command? It's telling me that the container name is already in use by the container, but there's no container that is running. So that now brings us to another command that would list all. And what does all means? It means list all dead and running container. Because when we stop that container, it just exited and is dead. So by the time I run this command, can you see? It exited. But I cannot run it again because it is seeing it as saying there is a container running, whether it is dead or alive. So how do I remove this particular container? Remember the concept of Docker remove image, the image name? The same thing here, Docker remove. You will now copy the Docker ID of what you want to remove, or you can specify the name this way, the name of the image, and okay, yeah, you cannot specify the name of the image this way. So Docker remove. Okay, sorry, you have to specify the container ID.
No, you did not put I. You did not RMI.
No. Remember that we are removing a container.
Oh, okay.
So if we need to remove an image, we have to just add the I behind. So let me run that command again. Docker remove the Docker container ID. Sorry. So it has been removed now. If I should do Docker container ls minus a again. You can see that it is gone. Or I can type docker ps. Either of the command we run, docker ps minus a, right? And or docker container ls. Either of it will run. So docker ps would show me all running container, while docker ps minus a will show me all container, whether dead or alive. So we can now go ahead and run that our command again in detached mode, and it should work. So can you see that I have run it, and it is allowing me to do other things because I have specified a detached mode, meaning detached from this terminal so that I can do other things. So if I come here and refresh this, can you see? So to feed our curiosity, let's do another thing. I can still run this same image, right? I can still run this same container, give it a name. Let's say we name it Lawrence container. Lawrence container, right? Give it 2000. Press enter. It will run. And just come here, change this to 2000. Same thing. Lawrence. Whatever I type here doesn't matter. It will output it because we have two containers that are running off the same image. And this is what Kubernetes latches upon. You know, that is what Kubernetes latches upon. That's why it's able to run different concept called pods. By the time we go to Kubernetes next week, right? It can run different, like of this same image. You can run 200 out of it. Kubernetes is that intelligent. Okay. So second to the last, right? We need to talk about a concept called Docker network, but I'm going to also add it as part of your assignment. Within the Docker, the Docker space itself, right? There's what we call the Docker network. So Docker network just helps with isolation. If you want some set of containers to be able to run within a particular network, you can place them in a network. If you want another one to run within a network, within a particular segment, place them in another network and run it. That is going to be an assignment for you. The last bit, which is very, very important, is what we call environmental variables. Very, very important. Now, remember when we were here, when we're talking about our webform.go and all, you know, I was changing this color from blue, I can change it to yellow, I can change it to this, I can change it to that. You understand? And what that means is that by the time I am running, a Docker container of what we have here, I want to have a way to be able to specify, to say that, see, look, if I change this color to white, or if I change this color within the code, within the code base to maybe purple, you know what will happen? I will have to rebuild this particular image because I have made modification within my code base. And that is why, as a DevOps practitioner, you need to ensure that best practices are built into the application that your developers are working on. And what are the best practices? The best practices is saying that you are telling the developer, whatever changes that is going to be frequent, that's going to be frequently used within the application, please, can you pass it as an environmental variable? Very important. Very, very important. I'm going to explain the concept right now. Now, part of the requirement is that application needs to be changing the color based on what I specify. So it means I have to always come here, change the color from white to blue, to do this, to do that, right? The first step is that for you to be able to avoid that, inform your developer to pass in environmental variables. And what are environmental variables? These are things that are changing naturally that you need to be able to control outside of the application itself. So you are extracting that information out so that whenever you need to make modification, you can just go to that, you can just point to that environmental variable and it will go. So let's do an example. Let's do an example. So remember this particular container that we ran. By default, what was there was what? Let me change to what was there. What was there was what? Was it white? Was blue, right? And that is why we have blue here running. It will always be blue. It will always be blue because that is what is inside the code. But I have told the developer, I was the one that actually did this though, but I've told the developer that please, I don't want the color blue to be permanent. How can I make it to be dynamic? How can I change this? The developer now say, okay, Mr. DevOps practitioner, I have heard you. I'm going to pass in environmental variables. Any method he wants to use to be able to pass in that environmental variable is none of your business. But the most important thing is that the environmental variable that it passes, you are aware of the environmental variable name. For example, now, what you can see here, right? I have passed in an environmental variable here. I called it what? Background_color. And within this code, right, I have defined the color that this background BG_color will be changing to. So how can I now pass another color, within this particular container? So let's say the users are saying that, please, just the way Ada said that we should change the color, right? How can we change the color?
Color green.
Good. One way we can do it is just to come here, change it to green, rebuild my image, run, no. So one way we can do this is still the same command, but first and foremost, let us stop the container. Okay, so I can stop the container this way. Just put docker stop. Let me get the docker PS, right? So docker stop. I can point to the container ID. I can point to this container ID as well, as many as possible. So by the time I stop this, it's good. But it has stopped. It has not removed. I only stopped it. So if I do docker PS, you won't see it. But if I do docker PS -a, you'll see it has stopped. But I need to delete it. What's the command again? Docker rm, point it the container ID. Point to this container ID as well. It's gone. So let us now illustrate what we are trying to do. Remember that this is the container. But because the developer has listened to my advice to pass in environmental variable, I can now go and ask the developer that, Mr. Developer, I want to pass in color green. Please, what is the environmental variable that controls the color segment within your code? We now say, okay, the name of the environmental variable is BG_color, which is what you can see here. So how do we now pass it? You will now pass it -e is what? I want to pass in an environmental variable. What is the name of the environmental variable? This. I'll copy it. I'll paste it here. What do I want to pass? Green. And enter. Right? So you can see that it is running. What is the port? External port is what? 2000. If I come here and change this to 2000 and refresh, can you see gray? Do you understand the concept now? So best practices are saying that as a DevOps practitioner, don't just allow your developer to dump applications on your lap. Follow best practices. So my developers know me today, right? If you don't do what I ask you to do, I will not build your application. Do you understand? Because that is when they will now say, okay, please, we need to do this particular modification, right? Then I will now have to go and start building, the entire pipeline. When I can just stop the application, if it's running within a Kubernetes cluster, I can define it within my config map, which I'm going to still talk about next week. Define it within the config map that, okay, so look, change the color to this. And I can scale the application. And the user will not even know that anything has happened. Do you understand?
Are you there?
Yes. Hello? Are you asking a question?
No,
I
no,
don't think
no.
that was for you.
Okay, good. So that is the concept of what environmental variables. I don't have to kind of like talk about this so that I don't skip it. Now, the last bit we're going to talk about right now is this thing I have here is worrying for me. It's worrying for me. Docker image ls. It's too big. And best practice is saying that, like, I have built my image. Yes, my image is working, but I'm concerned about the size. What do I need to do? I need to go back to my drawing board, Docker file. What is happening within here is that this go 1.19. Do you know what it has? It has all the full kits. It has all the full components that are needed to be able to run this application. But I don't need those kits. I don't need all of, just like saying that house that I showed you guys the other time, that's that wonderful house. This house, they finished building it. Now imagine the owner of the house entering the house and he's seeing shovels, he's seeing buckets, he's seeing extra sand, you know, he's seeing what else? He's seeing dirt, he's seeing so many things. It's going to make the house, let us say it will make the house heavy because there's something that you don't need. And that is what is happening here as well. There are some things I don't need inside this image that is making this thing to be heavy. The only thing I just need is just my dependency and my compiled application. That is all. Why do we have this 1.07 gig? And that's where the concept of multi-stage comes into play. The truth of the matter is that it is not all practitioners that know how to use a multi-stage, but I'm going to break it down for you, right? I'm going to break it down for you so that you can be able to understand how multi-stage build works. A developer will just stop here and say, man, I'm done. It has built, the application is running, but this is not good. This is too large. So how do we further break it down? What we'll do is we're going to make use of multi-stage builds. Right? Now, what that means is that we are going to have two images, two Docker images. The first one, which is the base, and the second one which is a lightweight image, just like Emmanuel pointed out, like an alpine image. That whatever it is that I've used here, I am done. Please don't pack your rubbish inside my final image. So we are going to introduce another image, which is going to be a lightweight, boneless image, like an alpine image. So an alpine image is just an image that is very, very light. Let us demonstrate an example now. Docker run, remember this command, Docker run -p, right? Let's say what 80. I want to run an nginx image, nginx. If I run this, Docker image ls, I want to run a particular container from nginx. If I run this command, can anybody tell me, is it going to run or it will fail? Remember that this image is not in my repository. It's not in my repository. So if I run this, can anybody tell me, is it going to run or it will fail?
It will run. It will download it and run.
Okay, it will download. Any other person?
It will.
Okay, any other person? Where will it download it from? Where will it download it from?
From the Docker registry or Docker Hub.
Yeah, from Docker Hub.
Okay, but why is he able to download this nginx image?
Because it's a public repository.
Exactly, because it's a public repository. So the rule of thumb is, by the time I am doing Docker run here, it will first come to my local repository and check, okay, do I have nginx? I don't have nginx. Let me go to the public internet and see if there's nginx. It will now go and run it. But guess what will happen? If I just run rubbish here, see what will happen. Can you see? It's telling me that I am unable to find Nginx locally. I am going to the internet. That now said, I have gone to the internet, so I cannot find this Nginx 8977 publicly. It might be a private, what is it called? A private image. I am unable to pull it. It's as simple as that. That's the rule of thumb. So let us now run the command. So if I run this way, it is unable to find it locally. It will now go to the internet to download it. So let us wait for it. I'm just trying to explain the concept of, the multi-layer. So let us wait for it. So if your Docker image, if during the process of running your container and it's taking more than 2 minutes, just know that there's something wrong. Your container should not take more than a minute to run. That's a secret I'm giving you guys for free. Your container must not take more than a minute to run. But if it's taking 2 or 3 minutes, just know that, man, the image is large. So let us allow this thing to just finish its demonstration. I'll show you an example now. So it is downloading the image. Now, this Docker run means that it would download the image and then run it as a container. So let's wait for it so that we can now quickly talk about how to be able to reduce. You can see it's even okay. So it is running now, right? But because I did not specify -d, it is just doing what it needs to do. So let us exit out. The most important thing that we want to check is the Docker image ls. So let me clear my screen and move this up a little bit. So Docker image ls. Can you see the Nginx? Look at the size. It's large. But I can still download a streamlined image that will still serve the same purpose, but that will be very light. And that is where the concept of Alpine comes into play. So if you should go back to this and type Docker Nginx Alpine, right? It's going to show you the same version of Nginx, but a streamlined version. So let's see, can you see Alpine there? So Alpine is just telling you that I'm going to give you the same image, but it's going to be very, very streamlined. So that is just what the Alpine does. So if I should come back here and type, instead of just typing Nginx, I just apply Alpine to it. It won't run because the spelling is Alpine. Let me even see the spelling. Is there an H in Alpine? No, Alpine. Okay, Alpine. So can you see what is happening? It's downloading its own. No? We're going to check the size of that image.
And the speed.
Exactly, and the speed. So then it took like how many minutes? I think like 2 or 3 minutes. So let's see how many minutes this will take. It still depends on the speed of your internet though. So let us wait for it and see the size. So it's done because I not specified detach. So I'll just stop the container and do the Docker image ls. What can you see? What's the difference between this Nginx and this Nginx? Can you see the size? Alpine and latest. So the same way we have for this, right, is we need to do the same thing here and specify that within our Go application, we need to specify a streamlined image like Alpine that does not have all of these other things that we don't need. So what do we need to do? We need to, from that Golang 1.9, right? Let us name this line. Let us name it build stage. I'm going to explain what I'm doing. Let's name it build stage. This is not doing anything. This is just, because I want to be able to reference this particular image within another section within my Docker file itself, right? But before I do that, let me do something so as not to confuse you guys. Let me just push this to my repository. Docker add everything. Oh, sorry. Git add all. So git status. So it just tell me that I've made modifications to this. Then I can just do a commit.
Git, not Docker, Git.
Thank you. We've been doing Docker since morning. Git commits. So added some other things. Okay, so let me just push so that you can use it. Git push set up stream. I want to push to my origin, my remote repository, and to the develop branch. Okay, so I've pushed. So let me now create another Docker file here. I'll call it Docker file dot maybe light, because we want to do a light file this time around. So let me copy what I have here. I'll copy it to this Docker lights, and I would now name this particular image. I want to name it as what, build stage, right? So I'm going to tell you what this is doing as we progress. So this as just tell me that I need to give this particular line a name, and the name is what, build stage. That is what this thing does, right? So the next thing now is that now I'm saying that after building, remember this point. After building the main application itself, here, right? Within this particular, between here and it's running the command, it has all of these jargons, all of the things that we've done here. And that is what is making that image to be large. So what I need to do is, I will now need to specify another image. And this is where the multi-layer build comes into play. I will now specify another image. Now, this image must be an Alpine image, or an image that does not have all of this rubbish that is here. Do you understand? So I'm going to specify another form. So that form is, so there are different base images that you can use. We can use Alpine images, we can use Debian images, we can use like different streamlined images. And what I want that to do is that, let's say I have named this base Debian 11, right? I've named this guy too. I want to name this build, let's say build release stage. This is just naming convention. What is happening is that by the time it gets to this place, by the time I have finished building my application, I am now telling Docker that, Docker, don't use this image again, no. Make use of this streamlined image. And I'm now naming, this step. I'm naming it as what? Build release stage, because this is what is going to be released. This image and the company we're going to define now is what is going to be released finally to what? To run as a container. Do you understand? So let us now go and look for that base. I don't know the full URL, but let's also look for that image. So you can actually use Alpine, you can use anything, but the one I usually use is this base Debian image, but I can't remember the full. I know it's a GCR. I know it's a Google Container Registry image. Distroless, good. So that is the name of the of the image. So let's see. What is the name of the image? I want to get the exact name of that image. Distroless base. Yep. So this is it. So this is what I'm looking for. Just can actually be anything, but because I've used this before, I can just copy this to here and just replace what we have here. So this is the name of the image itself, right? gcr.io distroless base Debian image. So now this Debian image is just a Linux image that does not have all of those heavy dependencies. Do you understand? After this is done, I will now remember that we are now inside. So forget this stage for now. This is now as if we are now inside another new image. So what do we need to do? Remember that we now need to what? Create a work directory the same way we did here, right? The same way we did here. And of course, I can just decide to create maybe like a root directory, or I can just name it anything. But the most important thing is that remember the concept here where we have to create a folder, where you have to create a folder and CD into that folder. The same thing is applying here. I'm creating a folder. I am seeding into the root file, into the root folder inside this image itself. What is now the next thing to do? Now this is where it becomes interesting. Well, I'm not saying that copy what? Copy from build stage. Right? I am copying from this build stage. So from here, from this part to this part is what is known as the build stage. But of course, this naming here is more like naming the entire processes before another from keyword. So I'm saying that copy from this particular segment, build stage. What am I copying? I'm copying my main, right? And I'm copying it and creating another folder inside this distroless, and I'm calling it main. That is all. That is everything that. So in essence, right? In essence, this has been built already. I only need all of the dependencies in inside this Golang image to only build the main. After building, I am done. Like, I am done. I don't want to copy all of those rubbish. That is why I am now making use of another image, a business image that does not have all of this rubbish, right? I am naming it as what? Build release stage. So all of these things here from the second from here is called the build release stage. And I'm now creating a work directory, just the same way I created here. And I'm now saying, see, copy from build stage. What am I copying? I'm copying main, what has been built, that has what? My software and the packages and the libraries needed. I don't need Golang to add his own toolkit. So I am copying that main, and I'm copying it to this what? To another main folder inside this work directory. So that this command that will now be run will now be this guy that has been copied. Do you understand? Then one last bit for security use. Okay, well, maybe we can just leave that. I'll just add that to your assignment. Is that by the time I run this, I am running as a root user. I'm running as a privileged user, which is not best practice, because anybody that gets hold of, just imagine a hacker getting hold of this particular container. It can run anything because it's running default as a what? As a root user. So I can just come here and specify that I don't want to run root, because by default, this is what is happening. Even if we don't place it, it's running as a root user and running as a root group. So I don't want to do this. I will just add none in front. I want that container to run as a non-privileged user. That is all. So what do I need to do? I need to save this. After saving this, let's now run the container. Let's now run this particular Docker file itself. So just want to ensure that I have Docker file lines. Now, the command is still Docker build. I'm tagging it, let's say, same ADA, but I'm going to tag it light version. Maybe light version, right? If I do this, what will happen? If I specify just that it should run the Docker file inside this particular directory, can anybody tell me what will happen?
It will run Docker file, not
Good.
Docker.
It will run the Docker file, but I don't want to run a Docker file. So I cannot specify that I don't want you to run a Docker file. I need to run the Docker file.light. I can now specify -f and what? Point to the Docker light file. Let's press enter and see what it will do. So, okay. Can anybody tell me what the issue is?
This is full stop. Is it the tag? The tag?
Nope. Look at it very, very well. I'm not performing magic. Look at it very, very well. Can anybody tell me?
You did put the present working directory.
Good. Please, what is your name?
Fumilayo.
What team are you?
Cloud champion.
Cloud champions, man. +10. Oh.
Thank you, Fumi.
Cloud champions. 10
Thank
marks.
you, thank you.
Good. That's a very, very good reasoning, because I just said, okay, specify this file, but where? I need to specify the dots. Do you understand? So you can see that we are running this thing together. I'm not cramming all of these commands because I'm also making mistakes, and you guys are, correcting it. So you can see it has finished running. So let's see, Docker image ls. Can you see the size? Where are we coming from?
Yeah, very, very okay.
Can you see?
We're coming from 1 point something gig now.
Exactly.
Wow,
And this is what people do not know. This is what DevOps practitioners do not know. Everybody will not be saying, okay, well, yes, DevOps, I can build. Show me your image. That's why I say, if your image is over 200 meg, then you are not doing best practices. Like,
quick question.
Yes, please go ahead.
So how do we know those images on the public repo that we can use for these build stages? Now, you said this base Debian is because you've used it before and all that. So how do we know images like that? How do we set?
You can use this as well. You can use Alpine. You can use just Google baseless images for maybe Golang or Java. They will come out in their numbers. Remember that I also went to Google here. You can see, and I searched for it. But because I was able to, because I've actually used it before, so I just copied it. See, so what they're saying is built upon the static image and include this whatever may required. So because I've actually used this before, right? This is what I usually use in all my projects. So you can have one that is just Alpine. That is why you don't need to just keep trying on the one that is actually going to give you what you need, right? So let's now run a container of that image. And that will be the end of the class for today. So, so where's the command now?
It's mommy.
So what's the command now? So Docker what? Can anybody tell me the command to run? Docker run the name. Let's say ADA lights, right? Maybe the ports. Let's say 50, and the point was I can detach it. And what? Anybody?
The name of the repository, and then the name we want to run it with.
That's all. So it's running. So go back to 50/50.
What's the function of that detached mode? Sorry, can I ask?
The detached mode, based on my understanding, the detached mode is more of like you want to continue working on the terminal.
On the terminal.
And at the same time, you want your container to keep running.
Good.
Okay.
Fantastic. So you can see I have run this light version, port 50/50, and this is what is running here. Same image, same what is it called now? Same process, but of course this is now a streamlined process. You can see that it's still the same content that we have here. So let me just show you one last thing here. How many images do I have running? Docker PS, right? I can actually enter that image. I can enter this image even and see what is happening. So the command is docker exec, right? Exec is I want to enter the image. Which image? Let's enter the first one and just specify a bash behind. Okay, sorry. I forgot IT, interactive mode. So docker exec, I want to enter this particular image and then interact with it. That is what this IT does. And then just press a bash behind. So you can see I'm inside that image. Let me do an ls. Can you see everything I copied? Go.mode, web.form. But where is where is this folder? Where is this main folder? Can anybody tell me where the main folder is? This main folder that we copied.
Right. It's in the root folder. Root.
Exactly.
Yeah.
So can you see the main? Can you see the main folder here?
Yeah.
So you can see that everything we've done is inside the container and we are good. So that brings us to the end of the class. I hope we all enjoyed the session.
Yes, it's actually.
Thank you so much.
But I think towards the end, for me in particular, I will need to watch the video and understand the end of the classes.
Yes, please. Yeah, so we're going to upload the video after now, maybe before 4 o'clock or before 5, thereabouts.
Okay.
Oh, that would be perfect.
Thank you very much.
Thank you.
Thank you.
All right. Yeah. Any question?
I have a little question, but because of time, maybe it will be later. I got like a time where we had to SSH into a virtual machine to learn how to do all this, run Docker commands, change images. So would we have an avenue where we can SSH into virtual machines and run commands to just understand better?
So what you can actually do is, see, I have my own terminal here, right? This is more like a Ubuntu terminal running on my PC. I have Docker here as well, Docker PS. Okay, well, maybe Docker is not running sharp, but I have Docker installed here. If you have a VM, maybe on AWS or on Azure, what you just need to do is just spin up your server. By the time you spin up your server, install Docker and you're good to go. Do you understand? Install Docker and you're good to go. So all the commands that I've done here is still the same thing that you can also do as well on your terminal. So the same way I am pulling images here can also be done on a terminal that has Docker running. Do you understand?
Okay. In addition, I will share on the platform. There's a there are playgrounds online playgrounds that allows you to run about 3-4 clusters or 3-4 nodes on a cluster, and you can have different clusters running together. So I will share with us where you can just practice. The only restriction with that one is that you can only have it run for 4 hours. After 4 hours, automatically they will time out your sessions.
Can you see my screen?
Just accommodate other people.
Yeah. Thanks,
I'll share with you guys.
So you can see the playground. It's free. I can just start and it will just take me. So here, I don't need to install, what is it called? I don't need to install Docker. So this is the playground. What I don't need to do is just to add a new instance. And can you see? And I'm good to go. Same command, same Docker image ls, same everything. Docker pull, Docker run, Docker run nginx. Can you see? Same thing.
Yeah.
Do you understand? So let me
That's
just do
nice.
the link here for you. So
okay, we should just say session 9 play with Docker. So see this.
Exactly. The same thing here. In fact, look at something. Let's even pull that our image. This image that we have here. Let's send it to our Docker hub. That's Docker image ls. So let's tag this Ada, the light version. Right? Tag it to what? Ada, same light version that we have here. Right. So Docker image ls right now. Then we'll do a Docker push. Remember, I'm still logged in. It's pushing. After it's finishing pushing, after it has finished pushing, we would now we'll pull it here. We'll pull it. Remember that this one is not even an environment. You can pull it here and run. Just a minute. Let me even be typing it down. Docker.
Okay, while at that, my question is, so on your Ubuntu, how do you check if the container is running? Because when you go back to your Windows, when you're using VS Code, well, you could go to your browser and see that the container is running. So Ubuntu, how do you do that?
On Ubuntu, you don't go to the terminal. See, so this is my command prompts. Just let us imagine, because I don't have a Ubuntu instance right now, right? I can just do a Docker PS to still list it, Docker image ls, because I have, my Docker desktop running. So the same thing, if you're on Ubuntu, I don't have my Azure account here. I don't think I have.
No, what I'm saying is, what I'm saying is, on when you were using VS Code on your local machine,
yeah,
you're able to go to your local host and then impute the ports.
Mm-hmm.
So how do you do that on, say, a Linux VM?
So for a Linux VM, right, by the time you run that image, it depends on where you actually run the Linux VM from. By the time you run that image, right, if that VM is within your environment, within your local, within your LAN, if you can, how do I even put it now? If you can telnet to that particular port from your system, and you know that you can actually telnet, then you'll be good to go. So you just point to the browser and call. So instead of calling the local host this way, so instead of calling the local hosts this way, you just call the IP address of that your Ubuntu. Let's say the IP address is 10.1.1.5 and point it to that point, port 8080. That's all. Do you understand? Because this is the IP address of the server. And of course, the port.
Can I share one like that for him to understand?
Okay, so we just need to end the class now because we are way, but you can just send me a message. Just send me a message. I will show you how to do that so that we don't keep everybody waiting on the call.
Okay, so I have a question, but this is point to Terraform. I have a serious issue which I feel that you can help me out.
Again, just send me a message, Emmanuel, so that I don't keep people on the call. Since it's a personal
Sir,
project, right?
I sent you a message last time. Really, you are